Hey, Jay with Rocky Mountain. Today we're gonna give you some really basic suspension setups. We're out here with Race Tech and we got Rob. He's gonna show us exactly what we need to do.
All right, so what we're gonna do is set sag today here. First thing we're gonna do is we're gonna take an extended measurement. We're actually gonna measure by hooking the tape measure to the axle itself. Then we're actually gonna put a mark on the fender. And what we're gonna do is we're gonna label it. What I typically do is look for a common number, something that's an equal number. Like usually you can find 630 millimeters, it's the most common number to be found. So what we'll do is we'll actually put a mark on the fender, put it at 630, and we'll actually write 630 on the fender itself, so we have an extended measurement to start. All right, next thing we're gonna do is actually get the rider to stand on the pegs. The reason we have the rider stand on the pegs versus sitting down is the number's more balanced and equal. So the rider can actually lean forward, he can lean back, and that number will never change as if he was sitting down. His body position can change that number really quickly. Now that we have him on board, what we're gonna do is we're actually gonna take this tape measure here, and we're actually gonna apply a little bit of pressure onto the shock and release it slowly and take that number. Next thing we're gonna do is we're actually gonna lift up on the fender and release it slowly, and we're gonna take that number. What we're looking for is the difference in that stiction zone. Typically you'll find somewhere between 0 to 5 millimeters is the most common for a stiction zone. So what we'll do is we'll average out the difference in the center between those two distances is actually our sag number. So if we have 630 as an extended number, and then we have 530 as our compressed number, and 535 is our extended and drop number, what we're gonna do is we're gonna get the difference there, and we're gonna see somewhere right around 97 millimeter, 97.5. We're typically looking for third of travel is what we're looking for. So we're looking from 33 to 35% of the travel is what we're using as a sag number. That goes from big bikes here down to little bikes. So, you know, a smaller bike's gonna have a smaller sag number, and it's all based on the travel of that motorcycle. All right, so looking at the sag numbers, what we're doing is we're looking for, on a big bike here, most commonly we're looking for sag numbers between 100 and 108 millimeters. If you're looking for a starting point, I'd say about 105 on a big bike. There's 25.4 millimeters per inch. So you're looking just over 4 inches for a sag number on a big bike. You're looking at 85s, typically 90 millimeters-ish. You know, your KTMs, you're looking right around 100. Your 65s, you might be looking in the 75 millimeter range, and your 50s, you're looking between 55 and 60. Those are pretty much your common numbers for sag numbers. Again, going back to a third of the travel. So if you just look at the travel of the motorcycle divided by 3, you have a starting point of where that sag number should be on that bike. Okay, we now have the sag set for our rider, and we're gonna look at somewhere about 105 is where we're running it currently. The one thing you'll notice here is we're running the forks flush with the top of the outer tube with the top of the clamp. The reason we do that is we're looking for a higher trail number. Gives it more stability, it actually planes off better in a rolling section, and it also makes it more stable. So that's kind of what we're looking for. The other thing to be noticed is if you ever have a harsh mid-stroke feeling in your front end, you just can't get rid of it. One of the things to look at is the way the front wheel is installed. You want to make sure that the axles are actually parallel to each other. One of the ways to do that is by tightening it on the caliper side, completely having the wheel free on the right side and having the the clamps loose, spinning the front wheel, locking the brake, and tightening the right side last. A lot of times that'll create a harshness, and that's usually the cause of it. All right, so we'll talk a little bit about clickers and what they do and adjusters and what the style of adjusters are per setup suspension. One of the things we have here, we have actually our low speed compression adjuster on the shock. Typically what that's gonna do for you is how much it's gonna squat, how much it's gonna roll through in rollers. It's mostly adjusts its ride height. It'll affect what it does on landings also. If you're on a hard packed slick track, you're actually gonna wanna soften your compression up compared to if you get into a really rutted track that there's tons of traction, you're actually gonna wanna stiffen your low speed compression up. Rebound has a lot to do with track conditions also. What we'll do is if it's really slick, hard packed, small acceleration chop, we'll speed the rebound up, keep the tire in contact with the ground at all times. If we have something where it's a big rut and the thing comes in and wants to hop out of the rut, what we'll do is actually slow the rebound down so we get one constant swoop through a rut and get a consistent feel. High speed adjuster on the shock is the bigger nut. KYBs are 17 millimeters, Showas are a 14 or a 12. It is not the big outer piece that will actually disassemble the shock, so make sure you stay away from that. When adjusting the high speed adjuster, typically what we use that for is the bigger G-outs. You got big braking bumps, and you know, there's two ways that it's doing. Your bike's either kicking up because it's deflecting, or it's kicking because it's bottoming. So you kind of want to get an idea, you know, if the track's really bigger bumps than you're used to and you're having a problem, chances are that the bike's actually bottoming out, and you'll want to tighten the high-speed adjuster up. If you're in a really slick track, not much big jumps, stuff like that, and you're just looking for all-around traction and no edge to the rear, you'll actually want to soften your high-speed adjuster up. Those are the main adjustments on the rear end, minus the sag and tuning the dynamic ride height of what you're looking for. Going to the forks now, the forks are kind of the similar deal. Our compression adjuster is going to affect how much it dives, how much it goes through the stroke on landings, how plush the initial feel is. That's your compression adjuster. So you're going to typically want to have that right in the middle as a starting point. And if you're blowing through on landings, you might want to go 2 to 4 clicks in. No huge changes. We usually say 2 at a time is the way to go. If you're on a really slick track and there's not really much jumps, you're just trying to take the edge off again, soften up the compression. We'll talk about rebound. The rebound adjuster is actually directly underneath the fork coming up from the bottom, and it is the same. Screwing it makes it slower, screwing it out makes it faster. If you're in a track and you need the front end to actually stay down in a rut, you actually want to slow it down. If you're having any problems with the front end springing back in a rut, same thing, you're going to want to slow it down. If you're on a track that's really slick, it's got a bunch of acceleration chop, or it has an edge to it, you're going to want to speed it up. So if you're entering a corner and it's fine there, and it's the exit is where you're not being able to finish the corner, what I would do is I'd speed the rebound up, because typically what's happening is the rebound is actually too slow and the front wheel is actually skipping out. So if you actually speed up the rebound, it will release itself and continue to keep you on the inside line. So now we're going to talk about springs. This spike has already been set up for spring-wise for the rider that we're working with today. This specific motorcycle has air forks. A lot of the motorcycles use spring forks. If there's anything you want to do to a motorcycle to get it in the ballpark of a good working motorcycle, springs. Springs, air pressure, that's your starting point. That's what you want to change. Air forks are becoming more and more common, so we're actually working with those today. One of the things we'll do is we'll actually pull our straighter cap off, and what I like to do is I like to hide the cap right here in the front of the seat so I don't drop it on the ground and go chase it in the dirt. What we'll do is we'll use our gauge. We got a nice works connection gauge here. What you'll do is you'll actually screw it onto the fork. Make sure that's completely snug till you actually get a reading. And then what we'll do is we'll look at it, and on this motorcycle we're going to run 34 psi, and we're currently set at 34 psi. So this one's actually good. These tools are really nice. What there is a zero loss system, and what they have is they have a fill that actually will not release air, so you can get a consistent pressure. Make sure always to set your cap back on. And that's the most common on that. On the spring style forks, you'll actually want to release the pressure, not on the air forks. Just on the spring forks will you release the pressure every time you ride the motorcycle. With the air forks, you'll want to make sure you check the air pressure every single time you ride the motorcycle. Feel anything weird, first thing you want to look for is that air pressure. Maintenance. A lot of people ask, how often should I rebuild it, or what should I do to maintain my suspension? This is what I'm going to say. I'm going to say that maintenance-wise, you should rebuild this stuff anywhere between 20 and 30 hours. If you are running more in a dusty scenario all the time and muddy scenario and stuff like that, you're going to pull more dirt into the suspension even though it is a sealed unit. Shock-wise, and fork-wise both, these are both coated components, and being that they're coated, a lot of people go, well, I've had my suspension for 10 years, did nothing as far as rebuilding, and I haven't had any problems. That's fine. A lot of times you can get away with that. The reason we say 20 to 30 hours for a rebuild is everything now is either Kashima coated, anodized, they're all really high-end components. If you don't rebuild them, what happens is the oil gets contaminated, and when it starts to do it wears at the piston band, the valve body, the shock body, the fork cartridge body, so it starts to wear your coating off. Once you wear the coating off, there's nothing protecting it anymore, and it's basically like polishing aluminum into the body, and what it does is it contaminates the oil instantly and starts to destroy your component. So maintenance-wise, getting them always freshened up and keeping them up is the way to go to not have to replace components and have expensive, repairs down the road. Other also is the fork tubes themselves. The reason we get fork seal leaks, and everybody always wonders, typically what's happened is you've either got mud on the fork, a nick in the fork tube, or something that actually has penetrated the seal and put a tear in it, or just literally has dirt underneath the seal. So that's the most common cause of fork seals. It's not really necessarily going to last 5 minutes or 5 years. It just depends on what you get on the fork tube. All right, so hopefully some of these basic tips that I used today as far as sag and ride height and adjusters, hopefully that'll help you get, you know, a good starting point and what you can use in the future. And, you know, hope you do the best, and wish you luck and have some fun.